The definition for exothermic is pretty simple. And so now let's give you a simple definition. Now, you can kind of think about this in a couple ways. Exothermic, the term exo is sort of like when you see an exit on a door. Exit usually means out, right? Okay, fair enough. So if thermic relates to heat, that means that exothermic means heat going out. It's exiting. So exothermic, if you have something going on, you got a reaction happening here, and you got stuff going on in there, and all of a sudden you get this heat, and the heat is coming out of the reaction system, and you feel it. So put your hands here, and you got some really weird looking hands right here. I don't know, like wolf ear hands or something like that, or I don't know what's going on with your hand here. But if your hand is feeling the heat, then that's an exothermic reaction. The heat system, the chemical system, is losing the heat to the environment. And endothermic, endo means inside. Thermic, again, meaning heat. That means if we had a situation where you had a reaction happening and you had heat flowing into the reaction. So this reaction probably won't happen unless there's enough heat outside to go into the system and make it happen. So if you got your funky looking hand again here, I don't know, serious issues with your hands, then what you feel is if the heat's coming away from your hand, you feel cold. It's like those chemical ice packs when they crunch them, there's a little bag, and they put them together, and then the coach says, "Oh, we'll make it feel better," and then because they can't give you like prescription drugs and stuff, so they crunch this bag up, and that bag is an endothermic reaction, and so ends up becoming cold. Now, in this situation, our little volcanic ash issue here is an exothermic reaction because it's plus heat. It's producing heat out into the environment. So it's producing 173 kilojoules of energy. That should be something you're familiar with. So this reaction releases heat into the environment. So if you had your funky hand up here, okay, it's just getting worse, then what would you be feeling? That's right. You'd be feeling some heat coming off. And this would be 173.6 kilojoules every time this amount of stuff is mixed together and that amount of stuff is formed. All right, so heat energy is absorbed when bonds are broken, and heat energy is given off when bonds are formed. So in that situation, if we have something here, let's take a look at water. Now, if we have water, which looks kind of like this, like that, and it has what's called a covalent bond right here, and that means that the electrons that hold these two guys together are shared between the elements. Now, if we were to snip those, like snap, 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 and break them, it takes from the system to do that. So there's lots of energy coming in here, and then the bonds will break. Now that you have hydrogen cruising around here with electrons, and oxygen's cruising around with places to put those electrons, other elements have the opportunity, like calcium, to come on in here and swipe some of those electrons. And then new bonds are formed. Calcium oxide is formed. And then you get, calcium hydroxide over here. So you get OHs that now form with calciums, and those are formed. So you're making new bonds, and when new bonds are made, then heat is released. Now, if you release more heat, so if you've got more heat, I almost wrote hotness, but if you've got more heatness coming from the bonds you form than taking in when you break them, then it's an exothermic reaction, and energy comes out. All right, that's pretty simple, straightforward. If you have any other questions, ask the director. That's me.